Hello everyone, welcome back to Intro to College Chem. Today we're going to continue with significant figures. However, this time we're going to do addition and subtraction and finding out how many significant figures you should have in your solution. So the number one rule you need to know is going to be number of significant figures is determined by the least precise value, and this always stays true. So what do we mean by that? Let's go look at some examples to get a better picture of it. So here, in this first example, we have 18.70 grams minus 1.170 grams, right? So the easiest way to find out which one is the least precise is to set them up as if you're actually going to subtract them. In this course, you have the perk of being able to use a calculator, so you're usually going to be able to just calculate it right away. But for the purpose of easily finding which one is least precise when you're first starting out, I recommend you set up the decimal places like this as you normally would, and you can determine which one you don't, or which significant figures you don't need based on the one that's sticking out. So in this case, this one right here, that 0 is sticking out like a sore thumb, and that's because although these both have 4 significant figures, when it comes to addition and subtraction, it comes down to where the decimal place is, unlike multiplication and addition, which there's a video in the description if you'd like to see how that process works. Anyway, so in this case, we're trying to go for the least precise, and as we can see, the least precise would have to be this one because it's only 2 decimal places to the right, or yeah, 2 decimal places to the right of the decimal place, compared to this one, which has 3, right? So this one would be considered more precise. So we're going to have to go with that top one, and if we're going by that top one, then we're going to have to automatically cancel out that 0 because we don't need it, right? We're going off the least precise, which just so happens to be the one with only 2 decimal places. And now that we know that, well, we use our calculator, our answer is going to be 17.53, and instead of having to add that 0, we don't need to. We canceled it out, and since the answer that we got lines up with the amount of the precision that we need based on the least precise one, our answer is going to be 17.53. So we can just go ahead and write 17.53, and we got that straight from the calculator. So again, this is kind of like a way to find out which is the least precise. Once you get a good idea, you can start to see that it just comes down to which one has the least decimal places to the right, right? But in this process, you want to get practicing. Let's do it one more time. And here we go, 16.51 grams divided by 0.7 grams. So right away, before we even set it up, we can see that the 0.7 grams is the least precise. And just to show you how that process works when we set it up is that here we have the 0.7, what's sticking out? It's the 1 that's sticking out. So again, we repeat the process and we can just get rid of that 1 that we don't need, right? In this case, when we use the calculator, the answer is going to be 17.21. But like we said, we don't need that extra decimal place on the right side, right? So in this case, we would have to cancel this as well and just go based off, like I said, the least precise, which is the 0.7. And in this case, when you have to cancel off from the final answer on your calculator, all you have to do is round. In this case, since it's 2 and the value right after it is 1, we can just round down to 17.2. So our final answer for this one is going to be 17.2. So again, the process is to just set up the decimal places, see which one sticks out, cancel it out, and just go based off the least precise one. In this case, 17.2, which is 1 decimal place to the right, and our least precise, as you can see, is 1 decimal place to the right. So again, once you get to practice, you can kind of just get it down, and you don't actually have to set it up. You can just go based off what you see in your calculator. But let's just keep going, keep practicing, and once you get a good idea of it, you can go ahead and do it with your own homework problems. Anyway, the next one's going to be 18.67 grams minus 1.200 grams. As you can see, this one has 4 significant figures. This one also has 4 significant figures. But like I said, the process is based on where the decimal is. So again, let's set it up. What's sticking out? It's that 0 yet again, so we can just cancel out that 0. Fortunately for us, when we actually do it in the calculator, it comes out to 17.47. Nothing's sticking out, everything's in line. So our answer is going to be 17.47. And that's how you know how many significant figures. Let's do 3 more examples, a little bit quicker this time, just so we can get a better idea. Also, almost forgot. Quick reminder, whenever you're doing problems, don't forget to put your units, because a lot of professors like to deduct points. So yeah, my mistake there. I almost forgot the units. All right, so let's keep going. 17.770 milliliters plus 6.9 milliliters. So let's set it up yet again. What's sticking out this time? We have actually two values sticking out, right? So we have that 7 and 0. It's 3 decimal places to the right compared to our lesser precise one, which is only 1 decimal place to the right, as you can see here. So in this case, we would actually have to cancel out those two values, and the answer we get from the calculator is 24.67. And as you can see, that answer kind of goes into the cancel out zone, and we need to just be in line with the least precise one here. So we would have to round this 6 up to a 7, right? So our answer in this case would be 24.7, my mistake, 0.7, there we go, milliliters. So yeah, that's how the process works. Even when you have like a more or way more precise one compared to a lesser precise one, again, you just go by the lesser precise one, which is 1 decimal place to the right. Your answer is going to be 1 decimal place to the right. And that, like I said, that rule always stays the same. So let's try this one again, or this next one, 19.9 plus 14.500. Again, we have 2 sticking out, and that's going to be cancel, cancel. Fortunately, our answer in the calculator only goes 1 to the right, which is exactly what we need. So no changes needed there, and we can just put 34.4 milliliters is the answer. So again, just go by the least precise one. All right, so last one, 17.700 milliliters minus 14.9 milliliters. In this case, yet again, we have 2 sticking out. We don't need those. That's too precise, going by the least precise. So our answer, even in the calculator, comes out to 2.8. So again, no changes needed here, and we just leave it as it is, 2.8 milliliters. Okay, so just to kind of recap, easiest way to do it to find the least precise is to set it up like this. Set up the decimal places so you can see where exactly each value is supposed to go, and then just cancel whatever you have sticking out to the right. And then once you get a hang of that, once you get a little more advanced, you can just go without setting it up, just go based off the one that's least precise. 1 decimal place to the right, okay, my answer is going to be 1 to the right. 1 decimal place to the right, my answer is going to be 1 decimal place to the right. And the pattern stays the same, even in the previous examples. Here we go. The least precise was 2 to the right, answer is 2 to the right. Here we have 1 to the right, answer is 1 to the right. And then here, least precise, 2 to the right, answer will be 2 to the right. So yeah, once you get that system down, it'll be pretty easy to be able to do it as soon as you see it and you won't need to set it up. But here's a few examples to get you going, and best of luck.